Hi, this is Fazana again. In part 2 of this topic, we'll look at more questions involving Pythagoras' theorem. Please watch part 1 before watching this video, just so that you're comfortable with the basics. Let's just have a small recap on this. Okay, so if the length of the hypotenuse of a right angle is C, and it's always the side opposite your right angle, then if you want to find the length of the longer side, we go a squared plus b squared, and if we have to find the shorter side, then we're going a squared equals c squared minus b squared, so the longer side squared minus one of the shorter side squared. Okay, in a non-calculator paper, try to do it all in one step. So c would be the square root, because we know we're going to square root at the end, and then you've got a squared plus b squared. Okay, and as long as you've got them in brackets, it's taking the square root of the whole amount. To find the shortest side, so let's say if we wanted to find a, we go the square root of, in brackets, c squared, the longer side, minus one of the shorter sides, and out comes your answer. Okay, so keep it really simple rather than making it really complicated and working out the square roots. And okay, let's have a look at some questions. Okay, here we've got triangle ABD and BCD are right angle triangles, and sorry, questions disappeared. It says work out the value of x. Okay, so the length of side BC. Okay, usually when you have two triangles, you know you're going to start off with the triangle that doesn't have what you need. Okay, so over here you can see you've got a right angle triangle, the side opposite your right angle is the hypotenuse. So we need to find this side because it's the common side to both the triangles. Okay, so BD equals the square root of 10 squared, the longer side, minus 5 squared. Okay, and once you put that on your calculator, you'll get 8.66. Yeah, it comes to 0. Let's just carry a few more decimal places, just in case they ask you to put your answer to 2 decimal places or 3 significant figures. So let's say we'll put it to 3 significant figures. Okay, so carry 4 significant figures in your calculation. Okay, here, once we've got that 8.66 centimeters, you know the side opposite your right angle is your hypotenuse, so it'll be the longest side. So you've got x equals, and this time because you're trying to find the longest side, you're going 4 squared plus 8.66 squared, and your answer is 9.54 centimeters. Yeah, and you can tell that's to 3 significant figures. Okay, as easy as that. So remember, if you get 2 triangles, chances are you've got to work on this triangle first, and then come down to that triangle. Yeah, just a tip. Okay, let's try another question. Okay, it says triangle ABC has perimeter 20 centimeters, AB is 7 and BC is 4. So let's just label the triangle first. So you've got ABC, so just draw a sketch, it just makes it easier. So AB is 7 centimeters and BC is 4 centimeters. And we have to deduce whether triangle ABC is a right angle triangle. Okay, so if the perimeter is 20, then we know side AC will be 20 minus the 7 plus 4. Okay, and the 7 plus 4 comes to 11, so 20 minus 11 is 9. So this is 9 centimeters. Now we have to figure out whether this is a right angle triangle. Okay, even though we've drawn it like one. Okay, so all we've got to decide is 9 squared equal to 7 squared plus 4 squared? And this will usually be given to you in a non-calculator paper. So let's just calculate. So 9 squared is 81, 7 squared is 49, and 4 squared is 16. So 49 plus 16 comes to 65. And 81 is not equal to 65. Yeah? So that means it's not. So no, not a right angle triangle. Angled triangle. Okay, yeah, good. Let's have a look at another question. I hope you like the way my ladder looks. The ladder is 6 meters long. Okay. The ladder is placed on horizontal ground resting against a vertical wall. So that's the wall. The instructions for using the ladder say the bottom of the ladder must not be closer than 1.5 meters from the bottom of the wall. So that's the bottom of the wall. So this cannot be closer than 1.5 meters. So it has to be greater than. Yeah? Okay, so if it has to be 1.5 meters or less, or more, then we need to find out how far up the wall the ladder can reach. So again, you can tell we've got a right angle triangle. That's your hypotenuse. So let's find how far that can reach. So we'll just call it x. So x equals, and then because we're finding a shorter side, it's 6 squared minus 1.5 squared. And we get 5.81 meters. Okay, so the ladder can reach 5.81 meters high. And give your answer to 1 decimal place. So we've got 5.8 to 1 decimal place. Okay, good. Okay, next question. Okay, here, how tall is this shed at its tallest point? Again, this is one of those questions where you think, what topic is this? So start writing something. And when I sort of look at the diagram, I think, oh, if I actually drew that line, then that distance there would be 1.8 meters as well. Yeah, and the minute I draw that line, can you see we've got a right angle triangle, and that is also 2 meters, the horizontal length. So here all we need to find out is this x here. Always prepare your question, so you know once you're trying to find your x, so you know when you find your x, we're actually going to go 1.8 plus whatever we find. So once you write that close to where your answer is supposed to be written, then you're 1 step ahead and you've prepared it. Okay, so we're actually trying to find one of the shorter sides because that's the hypotenuse. So again, we're going x equals 2.2 squared minus 2 squared, and you get 0.917. Okay, and then once we've got that, we stick it in here. So can you see now you don't actually have to look at the question again. Once you've prepared it, out it comes. And we've got 2.27 meters to 3 significant figures. Okay, yeah, good. Okay, let's have a look at one more. Okay, Pythagoras is often hidden within a question relating to circles. So in this case, a mirror is shaped like a part of a circle. The radius of the circle, center C, is 24 centimeters. The height of the mirror is 35. Calculate the length of the base of the mirror. So we're looking for that bit there. Now again, I keep lining it until I can find something in the diagram. So you can see I'm actually trying to make the diagram my own. We have a right angle triangle. Yeah, we have two right angle triangles. Okay, so we've got a right angle triangle there. Your 24 is the radius, so that's your H. What else can we... we've been given the 35 there. So if from there to there is 24, which is the radius, then that length there must be 11. So once we found this area, we'll multiply by 2 and we'll get there. So again, can you see? I'm preparing my answer and I'm going to put times 2 here. Okay, so once I find that length, I'll just go put it in there. So again, let's call that x, our favorite x. Okay, so x equals, we're finding a shorter side, so 24 squared minus 11 squared, and we get 21.33. Okay, we go stick it in there, and out comes your answer. And again, if you want it to 3 significant figures, 42.7 centimeters. Okay, good. That's all for now. I hope that working through these questions was easy, understandable, and fun. Remember, it has to be made fun for your brain to agree to absorb this information. By making it fun and putting rhythm into it, made it possible for me to have retained all these methods when I started tutoring in maths, years after I'd done my GCSEs. Keep working hard, and remember, you're in control. Until next time, take care. Bye.